Well, good morning. This was supposed to be the video where I make the black bits of the car all nice and shiny. But instead, and you might find this hard to believe, my Land Rover isn't very reliable. In fact, it's broken. So in this video, we're going to figure out why the ignition system doesn't work properly, run through a full diagnosis of the EFI system to figure out if there's any reason why I'm using more fuel than a container ship, and catch up on any deferred maintenance we come across along the way. All right, let's get started. So this is the acute problem that I need to solve, hopefully. This is the coil, the distributor's over there. I'm cruising along, engine cuts out, dead for a few seconds. Normally it comes back on, sometimes not, and I cruise to the side of the road, which so far hasn't been a big problem, but obviously that's a little dangerous. Sometimes it won't start either, which I assume is the same issue. This ignition coil has been replaced at some point with intermotor. And I'm not sure if the coil is good or bad, and I'm not sure if the coil is the correct coil. This capacitor has probably never been changed or checked, and if that was shorting to ground, I think that would absolutely cause the engine to cut out. So that needs looking at. And down in here you can see the distributor. Now when I got this vehicle, the leads and everything looked brand new, and so I assumed somebody had done the cap and rotor. That was not the case. When I eventually turned the rotor over, it was the original Lucas one, and it was stuffed. Hopefully I took some pictures of that to show you. So right now, because I had to get stuff locally, it's running a really cheap cap and rotor. And we're going to change those for better parts. We'll test the vacuum advance. I don't want to replace that for no reason because it's expensive. And fix up some of this wiring that people have buggered with in the past. Oh, and just so you don't think I'm a neglectful heathen, obviously when I started using the vehicle I changed all the oils, the coolant. Well, I had to change the coolant because it was bright orange and full of foam. Let's start here around the coil. In fact, first let's get the air cleaner out of the way so we can see what's going on a little better. I haven't actually changed the air filter. Maybe I am a neglectful heathen. Yep, there we go. I don't yet know if there's any problem with the coil itself, but I do know that the main HT lead has been leaking spark through the rubber boot, sparking all over the place. I temporarily solved that by cleaning the contact underneath, but all of this needs replacing or at least checking. Our primary resistance should be about 0.8 ohms. Let's have a look. Oh, okay. It's about double what it should be. What about in here? About 10, I think that's pretty typical. Those values are quite a bit different from what you'll see on a coil in a points type system. Yeah, 1.8 ohms. Okay. I suspect that this is not exactly the coil that should have been put in this vehicle. I'm not sure that that would be causing a problem though. It's not like it's completely wrong. Okay, so let's have a look at this one. May as well. Yeah, about 0.9, 0.8, 0.9, 0.9. So that's right on spec. What about the secondary out of interest? 8.7 kilo ohms. 8.7 kilo ohms. Also right on spec. Now before we fix this in here, we're going to look at this little capacitor. I'm very suspicious of this capacitor. So this small metal canister is a capacitor, or in automotive language sometimes called a condenser, and sometimes a suppressor. And this style of capacitor is ancient, like 1920s technology. This is what most capacitors have looked like since modern electronics were invented. This is an electrolytic capacitor. There's lots of different types, but this is very typical. The purpose of a capacitor is to absorb energy. either to use for something or just to absorb spikes in voltage, which is what we're doing here. If we look on the side of this thing, I've wire brushed it a little bit so we can read it. It's a bit hard to read, but that says 1 microfarad at 150 volts. So what that means is it can store up to 1 microfarad of energy and withstand up to 150 volts. Now you can't fully test a capacitor with a multimeter. We can check that it has the capacity that it says on the side of the capacitor. Okay, so let's see, we should have 1 microfarad. And we do not. 0.03 nanofarads, so that's about 3/100ths of 1 microfarad. So this capacitor is stuffed. But this in itself won't cause a misfire, I don't think. What I'm more suspicious of is that there is a short inside. When this jiggles around, the pluses might be touching the minuses and shorting out the whole system. In fact, you know what? Let's cut this open and have a look. Okay, well, it is a little crusty in here. There's quite a bit of corrosion. Obviously, water's got in. I can't see any burn marks or anything like that. Nothing obviously says there was a whole lot of sparking going on in here.
Regardless, this capacitor wasn't doing its job of being a capacitor, so it needs to be replaced, especially now. I don't know if I want to use one the same, because this style of capacitor is prone to failure due to the bad metal can packaging. Plus, I didn't think to order one. So what I'm going to use instead is one of these. This is a 1 microfarad 250 volt capacitor. The voltage is higher than the original, which is okay so long as it's the same or higher, but the capacitance needs to be the same, which it is. The problem with this capacitor is that it probably isn't fast enough, but I could buy this one locally, so it'll do for now. A capacitor or condenser in an ignition system needs to be able to fully charge and discharge hundreds of times per second, and most capacitors are rated at nowhere near that. But anyway, I think this capacitor will be fine temporarily, and I will either order a new original style one, Britparts sell them, or I'll trawl through data sheets and find a modern replacement that will work and last forever.
Now before I put this in here with the coil, we're going to clean up some of these other wires because they're dogs. Now when I got this vehicle, all of these wire ends were a twisty wire backyard mess. For some inexplicable reason, these two, which are the main wires that go to the distributor, were cut about this short with twisted wire and tape. Yes, the main ignition wires were twisted together with tape. And so I went and put these terminals on, which are useless. But it was a Saturday, and this style is all you can get from the auto store. For some reason, both Repco and Superheap only sell these garbage style terminals. They only sell this style with the single crimp, which is useless because there's nothing to support the wire. They're supposed to look like this. Notice this is the same brand that sells the crap ones in Repco. But if you order them from an electrical supplier, you get the proper double crimp version. So one crimp goes into the strands itself, and the other crimp goes into the rubber insulation. That's what Land Rover used. In fact, that's what every manufacturer of anything uses. See, these wire strands here are completely buggered. I could almost just pull this off. So I'm going to replace this, but let's just plug everything in now and see if it works. I better put the air cleaner back on just because there's a whole lot of crap sitting right here. Is that it? Is it fixed? It seems to be idling pretty steady and lower than it used to. think it should drop back down more immediately than that. I think there's more work to be done. Okay, at least it still works. Let's turn it off. Let's get all this old stuff out of here. You can see I've got two different types of plugs. These gold spark plugs on top, I got these about a year ago. I happened to be in Repco when they were on clearance and they were just basically dumping these for $1 each. They only had 5, that's why I got 5 of them. These were very fancy spark plugs. $23 each, normal price. I don't know what kind of mad lad pays $23 for a spark plug, but that's how much they cost. These are normal ones I picked up this morning. These are $5 each. I think $7 if you pay full price. But you can see the important part is the number. So the R just means there's a resistor inside the plug, which is to do with magnetic interference. Any plug for a modern vehicle will have a resistor in it. The N is the thread. The 11 is the important part. That's the heat range of the plug, and you can see they're the same. I think Y is the shape of the plug, and the last digits are whatever dumb features they put on. Like gold. I guess X stands for an extra $20. The point is these are essentially the same plug, so yes, I am going to mix them up.
Now, based on the fancy aluminium radiator, this engine has had overheating problems before, and possibly head gasket issues, and I know from the coil that the correct spec parts haven't necessarily been used, so it'll be interesting to see what plugs it's currently running.
Okay, they're NGK, which is annoying because we can't compare directly. BR4ES. Okay, I'll quickly go and have a look on the internet.
So, spark plug temperature relates to how hot the end of the spark plug stays. A cooler plug dissipates heat more quickly and actually sucks heat out of the combustion chamber as well, which is good. But a spark plug needs to be hot enough to burn off carbon and oil and to keep itself clean. Otherwise it'll foul up and misfire. If a plug is too hot, you'll get pre-ignition. The fuel will explode before it's supposed to, which is really bad. We're talking overheating, blown head gaskets, and in extreme cases, melted pistons.
Okay, so an NGK4 is the equivalent of a Champion 14 to 16. So that's too hot. Is it enough to cause problems? I've got no idea, but it's definitely too hot.
Anyway, let's get the new plugs in. Nothing really exciting to talk about. I did check the gaps. This one was a little extreme. But I had an extra plug anyway, so it doesn't really matter.
And now we'll get this cap out of the way. This cheap cap is pretty sloppy on here. We'll see if the Lucas one is any better. Okay, so while I've got the cap off, let's see if we can test the vacuum advance. So this is the vacuum advance here, and it basically just has a diaphragm in it, and when it gets sucked in this direction, it slightly turns this. So we'll unplug this hose and figure out how we're going to pull a vacuum on there. Okay, let's see. This is all I could find. I thought I had a bunch of big ones of these, but I either don't or I don't know where they are. And worse, this one is cracked, so I can only pull it back to about 6. We'll see if this pulls a vacuum. Not at all. Maybe it's not. Hang on. No, okay, that's not going to work. Actually, I'm not sure why that isn't working, because I get a really good vacuum if I just try it like this. Maybe the vacuum advance is bad. That would be annoying. Okay, I'm going to have to come up with a better plan. We'll leave that for now. Hi, it's me from the future. I've got one of these super cheap vacuum pumps. So let's test our vacuum advance. So this is how the pump works. If I hold my finger over the end, you can see we can just apply a vacuum. All right, watch the dial.
Nothing. Well, this is unexpected. Let me just check for leaks. No. Well, I was not expecting that. This vacuum advance is toast. Did not see this coming. I decided to send this existing vacuum advance away for repair, so we will come back to this near the end of the video. Yeah, nothing.
While we're set up on this super awkward camera position, let's change this. This is probably okay. This was kind of expensive, this rotor, to be honest. But I'll put a Lucas one in anyway. That's going to be fun to get off. It's pretty tight going on. And now the cap, which despite saying made in GB on the box, says made in Italy inside the cap.
Now, I'm obviously refreshing the whole ignition system anyway, but if I had to guess at the one single part causing the engine to cut out, I would go with
this. The ignition module, or amplifier module. And I think it's very likely that this is the cause of the problems. Now this is a computerized on-off switch. The distributor contains a Hall effect sensor and generates small electrical pulses that go through to this thing. Now the coil generates a magnetic field, and whenever a magnetic field collapses, the energy collapses into a voltage spike, and those spikes are what go through to the spark plugs. So all the ignition module, or amplifier module, does is receive a signal from the distributor and turn the power to the coil off each time. Now the amplifier module is right down in here on the side of the distributor. It's a bit of a bugger to get to. But I noticed while I was changing these belts that the module that's in here now is not an original one. It's some random aftermarket brand. So clearly somebody's been having trouble with that in the past. And if you remember, the original capacitor was stuffed, doing nothing. And that capacitor, of course, was designed to absorb spikes of up to 150 volts. So if that was doing nothing, where are those spikes going? That's right, the ignition module has been smacked in the face with spikes of up to 150 volts for who knows how long. So it would be no surprise if it is failing. Okay, it's right down in here. I'll show you on my phone. Can you see the little bit of writing down in there? That's it. I appreciate that all you can see is arms, but there's not much I can do about that. Okay, I'm there. Hopefully it can come all the way out with the screw still in it. Yep. Yep. Cool. Well, here it is. Gold standard. Made by McDonald's. Cool. Shall we open this old one up and see what's inside? Good plan. I don't think these are designed to come apart. Okay, well, I mean, nothing looks fried. It's got some weird jello-like potting in it. That's pretty cool. Okay, let's put the new one in. Now this new one, as noticed, came with a little pouch of thermal paste, which is nice. I have some, but we'll use this one. This is necessary so this thing doesn't cook. Now I'm going to spend an eternity putting these little screws back in. I'll see you later. You know, I started off today wondering what else I was going to do today. And here we are. So that got out of hand pretty quickly. I ended up having to, well, I didn't remove the distributor, but I pulled the vacuum advance off so I could turn it right around and then access those screws, because there was no way I could get them back in with the distributor sitting where it should. Now I did mark it and I have put it back in exactly the same spot, so the timing should be the same as before. I want to check the timing anyway, but I wanted to see what it was like before I touched it. I think I got it close enough. Let's attach all the leads, and then we can see if the motor still works. Ooh, new clippy things. All right, looks pretty good to me. All right, the last thing we're going to do in terms of the ignition system is check the timing. And I don't have any reason to think that the timing has been messed with, but we're going to check it anyway. And of course I will be doing that with a timing light. Now if you haven't seen one of these before, they're a pretty simple device. There's 3 wires, 2 of them go to the battery, and the other connection to number 1 spark plug. Now this part is a little different from what you'll see on any other gun because this guy is at least 50 years old, maybe 60 years old. On any newer gun, this just goes around the spark plug lead. This is a little old school. We need to jam something down inside the spark plug boot so that the screwdriver is making contact with the terminal on the end of the spark plug. I'm about to laser beam your faces. Prepare. It's obviously not in sync with the frame rate of the camera, but that's how that works. And if we point this down into the nether regions of the engine, this is going to light up a small mark on the front of the crankshaft, the harmonic balancer, I think, at exactly the moment number 1 spark plug fires. And that lines up with a little pointer. And as expected, the hardest part about this job is normally cleaning those marks so you can see them. Okay, so if we climb under the vehicle, I've already positioned them so we can see them. Now, if you look really closely there, you might be able to see the timing marks. This engine is not a good example. These are very faint. But I'll clean this up a little bit and show you again. Okay, so that's a little easier to read. Not easy enough though. So we're going to mark the correct timing position with a yellow paint marker. Okay, so here are our timing figures. Now we are in the high compression camp, and originally this vehicle was a cat vehicle. So we'll use the 5-degree figure. And now you always set the timing with the vacuum advance disconnected. Just pull that off. And now when I shine this strobe light down in here, it's going to flash and illuminate that yellow mark. It's really close, so I'm going to leave it alone. You can maybe get a degree or 2 more out of it, but it's close enough.
Now that the ignition maintenance is complete, apart from the vacuum advance, which is actually out of the vehicle at this point, let's take it for a drive anyway. See how it goes. It drives so much better. Even with the vacuum advance completely out of the vehicle, right now it's on its way to the South Island to be fixed by some guy. Even with the vacuum advance completely out of the vehicle, it drives so much better than it did before. It's a little hard to describe, but before there was this sort of hesitation on light throttle. There was always this slight, it just felt like it was being held back a little bit on light throttle, pulling away from intersections and things. That's completely gone. I wouldn't describe it as snappy, but boy, does it feel a lot better to drive now than it did before. Next, we're going to go through the fuel injection system. To be honest, I think all of the running issues have been solved in the ignition. But let's go through the fuel system anyway. One of the plugs was a little lean looking, so there may be a lazy injector. Plus, everything around the top of the motor is filthy. I want to clean the electrical connections and get at least the top of the motor clean enough to see any oil leaks. Check the vacuum hoses, stuff like that. There is, however, one painful preliminary task we need to get done. And that is change the fuel filter, which is located right under here. I've had this filter for a long time. In fact, it was with the first batch of stuff I bought when I first bought this vehicle. And I've attempted to change it before and gave up. So this is going to be a bit of a battle. But first, we need to release all the fuel pressure. And Land Rover want us to do that by removing the fuel pump relay, which is up in here under the dashboard, and then start the car until it runs out of petrol. Try again. There's 3 relays down here, so one of them must be correct. Okay, there we go. Yeah, so there's just this small bracket which goes up in here. This is the center console. It has 3 relays on it, and in my case the fuel pump was the blue one. I'm not sure if that is a consistent system or not. And there you can see the old fuel filter hiding. Let's prepare for battle. Okay. Oh, got it. Well, that wasn't too bad. I don't know what the dramatic build-up was for. Let's see about the other side. Oh, maybe this was the fight. Oh, that was pretty cool. I might go get gloves since I'm about to be covered in petrol. Oh, that's a lot of fuel. Okay. There was a bit of rusty goo that came out. It's water, I assume. Yeah. Oh, look at that scum. I guess this is all from condensation being trapped in the filter. Oh well, good thing we're changing it. Now we'll put the new one in, making sure not to get any smoo in anything, especially the downstream side. And before we move on, make sure it all still works, of course. Oh, that's sweet. But it still works. The next step is to confirm fuel pressure. This will check that the pump and fuel pressure regulator are working properly. And the car runs okay, so I assume that they are. But we'll also check for pressure drop with the car off, which would indicate leaking injectors. This is a bit of a hassle on these older EFI systems because they don't have a built-in valve for testing, so the gauge needs to be fitted in line. I made a couple of fittings and we'll loop the gauge in where the filter sits. And now we'll put the contraption in. I'll show you what it looks like afterwards. There's the valve that the pressure gauge will hook into. And you can probably see it better from under here. There's the filter. There's the temporary filter. So it's just doing a loop. Okay, so I'm about to start the car and we should see fuel pressure of between 34 and 38 psi. Yep, bang on. Now we're going to shut it off, and it shouldn't drop more than 10 psi in a minute. What does it say? About 28. No problem. It's within 10, and I did notice it dropped down immediately and then held position. So we know we have a good clean supply of fuel. Now it's time to check all the little bits that make up the EFI system.
So we are going to follow the test procedure in the service manual. This is how it's laid out, step-by-step procedure. I think there's about 30 odd steps, some of which we don't need to worry about. But before we get into that, we need to make sure that there are no air leaks coming into here. There's 5 or 6 vacuum hoses that are connected to this, and any air that's leaking in through them is not going through the air meter. And that could very well be why the idle surges up and down.
Okay, so on these engines, you've got a vacuum line coming off the top of the throttle area. That's for the vacuum advance. Mine's away being fixed, so we'll take that off. There is a small vacuum hose back in here that goes from the back of the plenum chamber to the fuel regulator, I think. It's back in there anyway. When I got this vehicle, one end of this hose was flapping in the breeze. And as you can see, this hose is in pretty poor condition, so I'll be changing that. And while we're back here, there's a larger hose going from the throttle to the idle control valve. Check that for splits. This hose is how air gets into the engine during idle. Next, you've got this big doofer. This is actually the crankcase ventilation system. The CCV system draws clean air through the bottom of the engine, sucking out all the noxious gas, which then goes through the combustion part of the engine. The CCV system on this vehicle is actually pretty interesting, but for now, check that the hoses aren't leaking so they're not drawing in outside air. On this side of the plenum chamber there are 3 vacuum lines that go off into the nether regions of the car. In actual fact, one is for the brake booster, one is for the fuel tank vapor thing, and the third line has something to do with the heater.
Now you really need a vacuum gauge of some kind to check these because there could be leaks in the fittings at the other ends of the hoses. In my case, everything was fine. So that's all good. Now let's get into the meat of this, the electronic meat. The ECU is located inside the driver's footwell, well up in here. You can probably see the big fat cable that leads to it. And sticking my camera in here with this going on is a little precarious, so I'll get it out and then I'll show you. And there it is. A little grubby. I'll give it a quick wipe down. Presumably it's sealed, so the inside should be clean. Now the way Land Rover want us to do this is we put the plug back in and we access the contacts from the back of the plug. The first check in the book is to confirm the resistance of your tune resistor. The 14 CUX is not programmable. You can't tune it on a dyno or anything like that. It did however come with a number of preset programs that can be selected depending on the vehicle options. You can see the list here. And you select the correct tune by changing the tune resistor, which is just a standard half watt resistor in this small loop of wire. Now there are some pretty big differences, the biggest being CAT versus non-CAT. The non-CAT tunes don't use any input from O2 sensors. The Australian tune is also different. Land Rover supplied Australia with a low compression donkey, I guess to punish them for being generally unlikable. Now in my case, this vehicle was originally a Japanese vehicle with catalytic converters. Of course they've been hacked out at some point. And of course whoever that munter was didn't change the tune resistor, so the computer was reacting to O2 sensors reading fresh air. It ran like arse. I've changed the resistor to a 460 ohm one, so it's now running on the standard UK Europe non-CAT tune. So in this step, the picture means ignition off and plug out. I don't know why Land Rover had to be so cute with these instructions, especially when it says ignition on right above it. But anyway, all we're doing is measuring across the resistor. And so we're just looking at the plug for this one. 27, which is this end guy here. And 5. What have we got? 1, 2, 3, 4, 5. Should be about 470, I think. 466. Perfect. Now this procedure is intended for a technician to sit in the footwell and diagnose the whole system without moving. But of course we could have taken exactly the same measurement across these 2 wires without touching the ECU. Battery supply to ECU, don't need to do that, we know it works. Ignition supply, we know that works.
Main relay for ignition on, we know that works. We know that works. Check engine speed cable and resistor. Ignition on, plug in. And we are after a voltmeter reading of 9.5 volts. Pin 39, which is the second to last one, and ignition on. (9.2). What did the instructions say? 9.5 plus or minus 1. Perfect. Fuel pump, fuel pump, fuel pump. Don't need to worry about those because we know it works. Purge valve. That is this thing right here. Disconnect pipe from purge valve to plenum. Connect vacuum pump to pipe. Apply vacuum of 2.5 inches of mercury, which should hold for 2.5 minutes. All right. Next step, apply vacuum of 2.5 inches of mercury and then connect pins 16 and 17 to earth. This is a pretty annoying setup, but I've got the two probes connected to earth and I'm going to touch pins 16 and 17 and you guys watch the vacuum gauge. 16, 17. What happened? It dropped to 0. Perfect. So this thing that purges stuff is working. Check injector circuit. Ignition off, unplugged. And we're going to measure the resistance between pins 2 and 13. And we're looking for a reading of 4 to 4.5 ohms. This is for the left bank. Okay, pin 13 and pin 2. 4.5, 4.4. Perfect. That's the left bank of injectors. The right bank are pins 2 and 11. 4.5, 4.4, 4.3, perfect. Okay, so the resistance readings for the injectors is correct on both banks. Check fuel temperature sensor, and we are looking for a reading based on this chart down here. What have we got? 2,500 ohms. What does that say in the book? Yeah, okay, a little less than 20 degrees, which is probably about right. The air temperature is 19, so we're bang on. Now exactly the same check on the coolant sensor, which is 25 and 7. There we go, about the same. Perfect. Oh, well, it was about the same. A smidge under 20 degrees, which is exactly what it will be. Now we're going to test the air bypass valve, or idle control valve. Inside here there's a stepper motor which moves in or out, and this is what controls the amount of air that comes into the engine at idle. This one in here in pin 1, and we're looking for 40 to 60 ohms. 51, that's approximately the middle. That's good. And now pins 28 and 29, and again we're looking for 40 to 60. Perfect. Okay, what's next? Okay, next we'll do the quick check on the airflow meter. This is what's called a hot wire meter. There's basically a small wire in here that gets hot, and as air passes over it, it gets slightly less hot. And more hot equals less resistance, cooler, more resistance. That's how the ECU knows how much air is entering the engine. Okay, but the static check is plugged in, ignition on, pins 25, 35. We're looking for 0.2 to 0.7 volts. Say 0.37 volts. And I assume if we were running the vehicle somehow while this was hooked up, we'd see the voltage go up and down. Alright, the last static check we're going to do is the throttle potentiometer. It looks like we're going to check its overall resistance first, and then check its swing. This is the throttle potentiometer here. So in here is the main throttle. This is what you open when you put your foot on the gas, and this shaft comes through into here. And this is a potentiometer, which is a variable resistor. And this is how the computer knows where our throttle is. Ignition off, plug out, checking the voltage between 3 and 25. 4.5 kilo ohms. What does the book say? Between 4 and 6. Perfect. So next Land Rover want us to take a voltage sweep
from pin 20. That means plug in the ignition on. I'm not going to do it that way. Instead, we're just going to check the resistance across the pot itself, which is going to achieve the same thing. I just don't want to be running voltage through the ECU while I'm prodding around at the plug any more than we need to. If we connect 2 of these pins, I don't know which 2, there's 3 pins, 3 wires. We'll just try 2 random ones to start with and put it in resistor mode. We get a reading of 4.5 kilo ohms, which was the same as we got inside the vehicle. Now if I move the throttle, you'll see those numbers changing. And it's dropping right down to 400 ohms.
A digital meter isn't very good for this test. Ideally, you'd use an old style analog meter and then you can watch the needles sweep smoothly. I don't suspect any issues, and I can see on the digital meter that there's no big jumps in resistance or anything like that. But the point is, the correct tool for this job is an analog meter. Okay, so we're done with static checks. Now it's time to go a little deeper. Just to be clear, I don't think this is necessary. But for the sake of science, we're going to pull the injectors out. Now, the injectors were stuck in the holes pretty good. I don't know if anyone has been this deep into this engine since the guy at Land Rover stuck it together. So it took a little muscle to move the 30-year-old O-rings.
Oh! Should have just done that in the first place. Now, Land Rover want us to test these by basically firing them into a cup. So these injectors fire 4 at a time, left bank, right bank, left bank, right bank. We can trigger each bank individually, but not each injector. So we have to unplug the 3 that we're not testing. Oops. I've got a cup, which we'll have to make a little more secure than that somehow, and a fire extinguisher, because, you know, this has the potential to get exciting really fast. And down in here, we are grounding pins, I think 13 and 16. One for the fuel pump and one for the injectors. And I've got pieces of copper wire hanging out of the socket because I don't want to be messing about with probes in there while this thing is live. So when we turn the ignition on, petrol should be shooting out of here. Let's go. Is anything happening? Nothing. Ah, the battery's disconnected. Okay, third time, ready. Oh yeah. There is 0 spray pattern. Okay, we're running this for a minute and then we're going to measure the output. Okay, 1 minute. Now. All right, let's see what we've got. Approximately 200 mils. 180 to 195 cc's using petrol, minimum. Okay, let's move on to the next one. Number 3, let's go. Sounds better. Oh, you're making a mess. Also just squirting like a fire hose. Okay, 1 minute. So what have we got? Looks about the same. I'll go put it on something flat.
And I'll skip through the rest because all 8 injectors were bang on. Just a smidge under 200 mils in 1 minute.
And you can guarantee I'm putting the petrol straight back in. This is about $10 worth. That's enough to drive this thing to the supermarket. So here are the 8 injectors, and we're going to give them a quick service. So we're obviously going to change the O-rings, even though these 2 that I've already taken off, they actually feel pretty good. And the filters. I think I'll start by getting all the O-rings off and giving them a quick clean on the outside. I noticed when I pulled these out that some of them had a lot of gunk in the filters. I don't know if you can really see that, but there's a whole bunch of crud in there. Next we'll do the filters. These are about $1 each, so you may as well change them. But you do need this special tool. Where is it? This guy, which is basically just a wood screw in a plastic sleeve. And basically what we do is get the little wood screw thing, thread it in, just until it grabs. And now we wind the end in, which just winds the plastic sleeve down. And pulls the filter out. There it goes. And then very carefully tap the new one in. Okay, that looks pretty good. And so on. Alright, now we're going to do some dumb YouTube stuff.
There are approximately 1,000 videos on YouTube covering DIY injector cleaning. Sure, you spray some cleaner through the injectors and flush out any gummy fuel. Most injectors look like this, with a series of tiny holes on the end so that the fuel comes out like a spray mist. These old style injectors just have a single big hole, like a hose. I'm not sure if they would have sprayed a finer mist when they were new, or if this is just the way they are.
The O-rings have arrived. Now I did not buy these based on the Land Rover part number. I sized these up and purchased them from the local bearing place. So what I've got here are 5/16 by 1/8 Viton O-rings.
I'm fairly confident that that is the correct size, and so far my Land Rover hasn't burnt to the ground, but obviously use that information with your own judgment. Now of course, there was a lot of cleaning and other problems along the way. These water connections were stuffed, so I made new ones. Same goes for this larger pipe thing. The ends are stuffed. I have not yet made new ones, but will have to soon. For now I dip the ends in epoxy. The CCV inlet or breather was clogged solid, and probably has been for years. I also replaced the foam filter. I cleaned out and painted the CCV flame trap, which was full of crusty solid oil, so that should hopefully work more efficiently now.
Plenty of never sees. Now get some of these vacuum hoses back in. This goes in here somewhere, somehow. That doesn't seem right. Does anyone remember what I'm doing? I might have to go and find a picture. Be back in a minute. Okay, so I can find nothing about this on the internet. There was one guy who made an entire YouTube video about it, and didn't actually install it. On my vehicle, it was stuck in here, like this. This is where it was when I pulled it out. Obviously, this makes no sense. It's shielding heat from something that's not hot, and something that's not hot. I believe it goes down in here, and attaches to the back of the alternator. And these little screw holes go into the side of the rocker cover.
I can see witness marks now that I mentioned that. So even though not putting the heat shield back in the correct place was a little bit lazy of whoever did that, I do appreciate the fact that they left it in the vehicle at least. Just hook it on to some random bolt. But at least it's still with the car. In the meantime, my vacuum advance made it all the way to the megatropolis of Milton. I had to Google where that was. Turns out it's between Milburn and Moneymore. Anyway, a guy called Wayne who runs a business repairing carburetors and vacuum advances repaired it. And I must say, it looks like new. I was expecting the internals to be fixed, but it was a pleasant surprise to see the outside looking so fresh. He peels them open and replaces the membrane, and I can barely see any evidence that this has been a part. I'd be interested to see how he does it. It was expensive though. I paid $190, which I think is fine. You can buy a brand new Brit Part 1 for less than that, of course, but I don't think that's particularly relevant. Anyway, let's get this in the vehicle and wrap this up. And after all that, it runs great. The obnoxious exhaust is a little distracting. But apart from that, it's probably pretty close to how it should be. It's amazing how much better it runs than it did before. Did you think this video was going to have a happy ending? No. Let's do a compression test. Now those numbers are pretty damn good. Nothing to complain about here. But the engine is possibly scrap metal. Back when I started using the vehicle, the coolant was orange and a tiny bit foamy, just under the cab. We don't get freezing conditions in New Zealand, so it's not unusual for cheapskates to run straight water in old clunkers. No big deal. I topped it up, it went low again. And again. I was losing about a litre of water every time I drove the vehicle. I couldn't see any leaks, so I pulled the plugs, and sure enough, the coolant had been disappearing through number 7. So I did what any normal person would do, and shoved some of this stuff in. And it's been fine ever since. Now hopefully, the left-hand head gasket is blown, because otherwise the block is cracked, which is unfortunately pretty common on these engines if they get cooked. And a cracked block is basically unfixable. So, I don't know what we're going to be doing about that. I guess I'll be pulling ahead fairly soon. But there's no point worrying about minor problems like that, because at least for now, I have a nice V8 that seems to be running really well. And it could do for a long time. Anyway, thank you all for watching. I'll see you next time.